All right, boys and girls, let's use these wonderful tools right here, our Dixon Ticonderoga number 2 and our TI 30 series calculator to answer these questions on a paper 4, Cambridge IGCSE. Number 3 here has to do with, oh man, geometry. This is a paper 4 from the spring of 2014. These are good things to practice. Yeah, let's do this one right here, shall we? Let's see here. It says in the diagram, AE is parallel to BC. Oh man, always make sure you read. The majority of mistakes occur because people don't read well. They don't read carefully. Same here for myself. When I mess up, it's usually because I don't read or I make some silly mistake. But it's usually this is the biggest one right here. Okay, so in the diagram, AE is parallel to BC, right? And CE, so CE, so this is an isosceles is equal to CD. So this is an isosceles triangle. This is a right angle. All right, tells us that there. This is 60, and that's 148. Okay, perfect. Find angle ABC. So this angle right here, angle ABC. So find that angle right there. Well, since these are parallel, this is co-interior. So that means these are supplementary. So it's 120 degrees, right? 180 minus 60. Just a 1 point question. So yeah, probably don't need to show work, but we could anyway, just to make sure. All right. Now, next up, find the obtuse angle AED. That's this one. Now look, that is a 4 point question. That's worth a lot of points. That means we probably have some stuff to figure out, right? And often the case is, and this is a clue, being 4 points, that means that you probably can't figure it out directly. Here's what I noticed right away though. You see this angle here plus this angle here plus this have to equal 360, right? Um, all right, the obtuse angle. Now, I know it means this angle because that's obtuse, not this angle. If it's more than 180, this is more than 180, that's called reflex. So I know that it's talking about this angle right here and not the whole thing. All right, now let's go ahead and figure this out right here. If this is 148, then this is 32. Let me make sure, right? Good idea. 148 plus 32 should be 180. Yeah, that's 32, right? And this is 90, right? So 90 minus 32 is 58. So these two angles right here, this one plus this one plus 58 have to add up to 180, right? So 2x plus 58 have to equal 180, right? So here's what we're going to get. We're going to get 180 minus 58 divided by 2, and that's what this angle right here is going to be. So we could do this in our head, but since we have a calculator, let's go ahead and use it. So divided by 2, right, 61 degrees. So 180 minus 61 plus 148, that should give us that angle right there. So 148 plus 61, and then 360 minus that number, 151. So this is 151 degrees. 151 degrees. Boom, done. So 4 points, that's worth quite a bit. Yeah, make sure you're showing your work. Make sure you write on the diagram. Be nice and neat. Okay, next up, Buttercup. Hashtag not to scale. Says the diagram shows triangle ABC. That's the entire diagram. And P is on, this point P is on AB such that it's a perpendicular bisector. So it's cutting this in half, right? It says use congruent triangles to show that this angle, CAB, is the same as angle CBA. So we're trying to show that these are exactly the same. Okay. Now, here's the deal. Because this is a perpendicular bisector, that means this angle and this angle are the same. And this is a right triangle, right? So what we actually end up happening right here is, well, you see how that's a right triangle? So let's take a look at this right here. Let's take a look at this. Look, we know that if we separate these two triangles right here, here's what we know. We know this side and this side are the same, and we know these two angles are the same, right? For sure. We also know that this side is the same, yes? Oh man, look at that. This is fancy. So what we have is we have a side, we have another side, we have a right triangle. Do you see? And we know those two sides are this. We know that this side and this side are the same. We know that they're both right triangles, right? this angle is the same as that because it's a perpendicular bisector, right? Perpendicular bisector, that means that this angle is the same, which means that these two angles are also the same. So what we have is we have side angle side. We have because this side right here is going to be the same as that side right there. We have side, angle, side, right? Angle in the middle is the same as this angle in the middle. So we have this side and this side are congruent. This side and this side are congruent. That means those two angles are the same. So side angle side. Side angle side. All right. Let's see. Is there more? Oh, of course there's more. It's like Christmas. All right, so what we've got a circle with a couple triangles right here, right? It says A, B, C, D all lie on the circle. That means those points are on the edge of the circle. Um, the chords AC, let's see, AC and chord BD, they intersect at point X, okay? Explain why triangle ADX and BXC are similar. So if they're similar, that means that they're going to be proportional. It also means if they're similar, that means that all of the angles, the corresponding angles, are going to be equal to each other. Okay, so let's see if we can do the angle front one, right? Let's see if we can take the angle, because I don't have enough information to show that they're proportional. But here's what I know. I know that this angle right here, we know that angle AXD is equal to angle BXC because they're vertical, right? For sure. This angle right here and this angle right here are congruent because they both lie on this same chord right here. It's not drawn, but you see this chord right here? They both lie on that chord right there. So angle ADB is congruent to angle BCA, same chord, angles that lie on a chord. And because of that, these two angles are the same as each other. And I know that's true also. They also lie in the same chord, this chord right here, right? And so they have to be the same anyway because, you know, the other two are the same, so they have to be equal. So angle DAC is the same as angle DBC, right? And we could say same chord, right? So all angles, all corresponding angles are congruent. Oh, sorry. All corresponding angles are congruent. So they're similar. So they're similar triangles. I hope that's good enough. I don't really know. um, I think I showed everything. All the angles are the same, so they're congruent. Okay. Next up, Buttercup, it says AD is equal to 12. CX. CX is equal to 4 and CB is equal to 8. So we see that on the diagram. And it says calculate the length of DX. So DX is this part right here. We want to calculate that. Here's what we got. We know that this and this, they're corresponding. These two are corresponding. So look, here's what we've got. We need dx. Dx is in the triangle, is in the bigger triangle, right? So I'm going to do big over small. And I know that 12 over 8, these are corresponding. So 12 over 8. And that's going to be the side I don't know divided by 4. Ah. Yep. So it's going to be 6. Multiply both sides by 4, right? Oh, not 4 over 1, or not 4 over 4, just 4 over 1. That reduces, so 6 is equal to dx. All right, that's good. So you just set up your proportion, knock it out, right? Now, the area of ADX is 18k square centimeters, okay? Find the area, find in terms of K the area of the smaller one. Well, let's see. We know that the small to big, the linear scale factor is 8 to 12. I'm going to go ahead and reduce that. That's what, 2 to 3. But that's linear. So if I square that, I get 4 to 9 for area. You see? I don't know the area of the small triangle. The big triangle is 18K. Right? 18K. So we can solve this. We can solve this. So I think it's going to be multiply both sides by 18, right? We can reduce 18K, 18 or over 1. Divide, that's 2k. 2k times 4 is 8k. Boom, done. Let's see, is that it? Oh, yes, that's it. Number 4 is the next one. So, number 3 is done. I hope it's been helpful. You guys are wonderful, fantastic people. Have a great day. Until next time, I'll see you on the flip side.